All right, so here are just a couple other basic geometric integrations, just in case you weren't quite sure how to do them without a picture. It says step 1, draw the function on the coordinate plane. Step 2, find the area. So here, if you look at this one, the function is 6. So if you think about that on a coordinate plane, it's at 6. That's a horizontal line. Here's my line, and I'm going between 1 and 5. So if you look at that, you have a rectangle, a 4 by 6 rectangle, so your area is 24, or your integration, your definite integral would equal 24. And let's look at this one next. 5 minus the absolute value of x. So if I graph that, it's going to be the absolute value, but it's upside down, right? It's reflected over the x because it's negative, but it starts at 5. 2, 3, 4, 5. And then it is going to go to negative 5 and positive 5. So it looks like this. So the area I'm talking about is underneath the curve to the x-axis. So this rectangle, or this triangle shape, the base is 10 and the height is 5. So we would have 1/2 10 times 5, which is 50. So 25 is the value of my definite integral. This next function, I wanted to put an example out here for this one. When I see this x squared and a square root, and that these are perfect squares. This is a semicircle. So it's a semicircle. It's going to go from -7 to 7. And at 0, if you put 0 in for x, it equals 7. So it's a semicircle above the x-axis because it was positive square root of that. So you would have this area here. So you would have pi r squared divided by 2. Your radius of this would be 7. So you would have 49 pi over 2, and it's positive. The next function here, 1 to 5 of 2x plus 1. So what I do is I'm going from 1 to 5. I know it's going to be a line. So if I plug in 1 in here, so I'm going to put 1 in first, that gives me 3. And then I'm going to go to 5, so I'm going from 1 to 5. If I put 5 in there, that's 10 plus 1 is 11. So that's at 11. And if I draw this, this is what I have. This is at 11 here. So this is actually a trapezoid shape. To find the area of a trapezoid, you can use the 1/2 height times base 1 plus base 2. A lot of students last year, what they did was they just cut it like this and said, I have a rectangle and a triangle. That works as well. So this rectangle here is 4 by 3, so this is area of 12. And then you have a triangle that has a height of 4, it looks like. This is 4, and the base is, this is 3, this would be 8, because this is 3, this is 11. So it's 4 by 8, which is 32, divide by 2 because it's a triangle, so that's 16. 16 plus 12 is 28. This last one, real quickly before my computer dies, another line. So if I put in -2, which is right here, I get -5. So there's that point. If I put in 3, positive 3, I get 0. So I have this shape here. I have this shape here, which is a triangle, but it's under, so my answer is going to be negative. I don't know why my pen keeps doing that, negative. So this distance would be 5. Here you're going from 2 to 3, so that's also 5. So you get 5 by 5, which is 25, but you want half because it's a triangle, so it'd be -12.5. All right. That is how we do some basic geometric formulas.